Quasi, mini, ghost moons, Earth's hidden satellites. We all know Earth has one moon. It has orbited our planet for over 4 billion years, stable, predictable, and familiar. But Earth's gravitational influence extends far beyond this single companion. Hidden within and around our orbit are strange objects that appear to be moons, temporary visitors that circle us briefly, and even moons that do not have solid surfaces. These are quasi-moons, mini-moons, and ghost moons, and they reveal that Earth's neighborhood is far more dynamic than it seems. The real moon. Our moon is a true natural satellite. It is gravitationally bound to Earth, orbiting at an average distance of about 384,000 kilometers. It completes one orbit every 27.3 days. Because it is tidally locked, we always see the same face. Meanwhile, Earth and the Moon together orbit the Sun once every year. This is a stable, long-term gravitational relationship, but not every object near Earth is so committed. Quasi-moons. A quasi-moon, or quasi-satellite, is not actually a moon. It does not orbit Earth. Instead, it orbits the Sun, just like Earth does. However, it shares nearly the same orbital period as Earth. This creates a one-to-one orbital resonance. From our perspective, the object appears to loop around Earth once per year. One known example is 469219 Kamoalawa, 2016 H03. It stays near Earth's orbital path and appears to circle our planet in a shifting, bean-shaped pattern. Earth's orbit around the Sun, blue, contrasted with that of its quasi-moon 469219 Kamoalawa, 2016 H03, yellow. The large yellow circle traces just one of the quasi-moon's orbits around the Sun. Over many orbits, it also traces the series of loops around Earth shown to the right. But in reality, both Earth and the quasi-moon are orbiting the Sun independently. They are synchronized, not bound. It's a gravitational dance, not a true satellite relationship. As of March 2026, 8 quasi-moons of Earth are officially recognized. Although many asteroids share Earth's orbit, only these 8 follow the distinct looping, moon-like paths that classify them as true quasi-satellites. The most recent addition, discovered in August 2025, has drawn particular interest. Some scientists suspect it could even be space debris. Astronomers plan to conduct spectroscopic analysis later in 2026 to determine its true nature. A quasi-moon comparison. Most of Earth's known quasi-moons are small asteroids roughly 10 to 400 meters wide, with an average size of about 100 meters. The real moon is 3,474 kilometers wide, so these quasi-moons are millions of times smaller. A 100-meter quasi-moon compared to some objects on Earth. Mini-moons. Mini-moons are different. These are small asteroids that actually become temporarily captured by Earth's gravity. They enter Earth's region of gravitational dominance, known as the Hill sphere, and begin orbiting Earth, but only briefly. Only 2 mini-moons completed at least one full orbit around Earth have been discovered and confirmed so far, although scientists estimate that several may be temporarily orbiting our planet at any given time. 1. 2006 RH-120, orbited Earth from July 2006 to June 2007, size, about 2 to 3 meters. 2. 2020 CD3, captured around 2016 to 2018, discovered in 2020, left Earth orbit in May 2020, size, about 1 to 2 meters. Their orbits are unstable and irregular. After a few months or years, gravitational interactions, mostly from the Sun, pull them away again. A confirmed example is 2020 CD3, which orbited Earth between 2018 and 2020 before escaping back into solar orbit. Minimoons are true satellites, but only temporarily. Earth does not hold on to them for long. Minimoons are harder to detect than quasi-moons because they are only a few meters wide and stay in orbit around Earth for a very short time. The reasons mainly involve size, brightness, and time. 1. They are extremely small. Objects this small reflect very little sunlight, so telescopes can only see them when they are very close to Earth. 2. They stay only briefly. A minimoon usually orbits Earth for a few months to a few years before escaping back into orbit around the Sun. Because they don't stay long, astronomers often miss the window to detect them. 3. They move very fast in the sky. Minimoons are extremely close to Earth, so they appear to move rapidly across the sky. Fast motion makes them harder for survey telescopes to track. 4. Most telescopes were not designed to find them. Many asteroid surveys were designed to detect larger near-Earth asteroids, not tiny meter-sized objects. Astronomers expect more quasi-moons and mini-moons to be discovered soon, especially when the Vera C. Rubin Observatory begins full sky surveys, which should detect many faint near-Earth asteroids. The Vera C. Rubin Observatory was already operational since late 2025, but 2026 is the year it starts full scientific surveying of the sky. Ghost moons. The most common scientific use of ghost moon refers to the Kordylewski clouds. These are large concentrations of dust that exist at the L4 and L5 Lagrange points of the Earth-Moon system. Lagrange points, L1 to L5, are specific points in space where the gravitational pull of two large masses, like the Earth and the Moon, precisely equals the centripetal force required for a small object to move with them. They are called ghost moons because they are exceptionally faint. They don't have a solid surface. Instead, they are massive clouds of fine interplanetary dust. They are nearly impossible to see with the naked eye and were only confirmed via polarized light imaging as recently as 2018 and in a follow-up observation campaign last 2021-2022. Quick comparison tables. Earth isn't the only planet with these hidden companions. Because the laws of orbital mechanics, like gravity and Lagrange points, apply everywhere, other planets have their own versions of these elusive moons. Earth may appear to have only one moon, but its gravitational reach tells a more complex story: temporary companions, synchronized dancers, and ghost moons.